Hey guys, this is Karan here. I live in Saudi Arabia, studying 10th grade in Yambo International School. Now what we need to do is recall that in solving linear equations, inequality, which was very much like solving equations, right? Well, now what we are going to do is turn the tables around and pay attention on polynomial inequalities. We already know too much about polynomials, so why not just involve inequality in polynomial function, using polynomial function. Now the method of the solution is not like non-linear equations. So let's go ahead and take an example and learn from those examples. Okay, so let's say for example we took x squared minus x minus 6 is less than 0. How are you actually going to solve this inequality? Well, factorization always takes place no matter what. Okay, so factoring this would give you x plus 2, x minus 3, which is less than 0. Okay, now the critical numbers that we find out is that what you need to do is think about it like this. X, wow, this is black marker. Oops, my bad. So you need to take this inequality, which is x plus 2, make it equal to 0. Then take this inequality, x minus 3, make it equal to 0, and get your critical terms. Now to find these terms you need to take out the bracket. You found out x to be negative 2, take out the bracket, x equals 3. Now you know this procedure, right? When you get here it's really easy for you because it's like solving equations, right? So now what we are going to do is involve critical numbers that we just found out. Now the critical number is what we say to this point. Critical number. Critical number that we found out is x equals negative 2 and x equals positive 3. Okay, now that we know this, let's go ahead and take an extra step further, which basically is to make a number line. Now making this number line like this, you can make it however big you want to. Okay, so then the next thing you need to do, negative 2, 3, this is the third, this is the second, and this is the first. Okay, now we then solve for the equations that, okay, so now that we have lined this up, now so what we need to do is, since we now found out the critical numbers that x is equal to, which is this terms, which is negative 2 and positive 3, what we need to do is we then solve for the solution that s interval, and it was created between the zeroth function. Now zeroth function takes place over here. As well. Okay, so you cannot escape from factorization nor the zeroth function of a function. Now you make these intervals and find out where the critical numbers are, which basically means what are the values that x can be. Is it between negative 2 and 3? Is it over here? Is it over here or over here? Well, what you need to do is take one point, which is negative 1 over here, put it over here. Is it less than 0? If it is, then cover this area up. If it's, you put negative 2 over here, negative 2, then x could be negative 2 here as well. So this would be 0. 0 times any number would be 0. So 0 is less than, no, it's not. So it's only this area. And then if you try to use the area over here, which is, you could be 2. If you use 2, 2 plus 2, 4. 4 times any number, that 2 minus 3, 1, 4. So it's not this over here. So if you use this 4, it's not this either. So you can see that it's only this number varying from right here. Okay, now that's the zeroth function. You can basically get the idea of a zeroth function. Now let's go ahead and use another example that we'll talk about. First one is always a little confusing. And again, if you still are confused, even at the end of the video, you can replay the video, focus on what I'm saying, because what I'm actually saying is very important. Okay, so for example, if we have x squared plus 2x minus 3 is greater than or equal to 0. Okay, so what you need to do is write it down again. X squared plus 2x minus 3 is greater than or equal to 0. Then you need to factorize it over here. That would basically be the second step. Plus 3x minus 1 is greater than or equal to 0. Then you need to find out, plug in that equation, and you need to find out your critical terms, which I already did that. So the critical terms, CT, critical terms are negative 3, x equals negative 3, and x equals positive 1. Okay, now what you need to do is, I'm going to tell you the easiest method. You don't need to use the number line to find out each and every solution, because there's a new method that I found out by learning, reading, and things along those lines, is that when you have this, okay, you basically take this values as a y values, right? So we can make a box like this, two boxes if you have two critical values. Okay, what you need to do is basically put negative infinity, and then this one, this critical term over here, which is positive 1, and then positive infinity over here. And what we put here is negative 3, and this is your answer. Simple as that. Now to make it more clear, let me just go ahead and erase this part up and write it down again, so you get the idea with a blue marker. Okay, so you have negative infinity, negative 3, positive 1, and positive infinity. Negative goes with negative, then positive goes with positive. Okay, that's the easiest way to remember this. Now what if you have a positive value over here? Well, it doesn't matter, because the first term over here is always the y value you put in, right? So when the y is whatever, even if it's positive, this over here has to be negative. Okay, now just to memorize this, kind of just to start with the kicks, I told you guys that I picked this quotient because it has involving the critical value over here is negative 3. So negative 3 and negative infinity would be easier to remember than the positive and negative and positive and positive. So that would just make it ridiculous on you guys, okay? So just for the kicks, I started with the negative numbers and negative, positive with positive, okay? Now you get the idea right now of what I'm talking about. Okay, so now you can even do this on number 9 if you wanted to. Now number 9 is basically like this. Now since we already found out this solution, okay, you don't need to plug in every digit. So how are you actually going to accomplish this task? So here we have negative 3 and positive 1 over here. Okay, now since you already said positive 1 goes till the infinity, okay, and the infinity we said is this side, so it's this side over here, okay, and it's including 1, because remember the quotient was greater than equal to 0. Okay, and this one would be till the negative infinity, which is this side over here, including negative 3. Okay, so what I mean is that negative 2, negative 1, 0 are not included. Okay, did not. Okay, easy as that. You don't need to check out every solution. This is one handy method that you need to use it to find out your solution, as soon as possible, because you don't, in exams like this, you won't have enough time for finding each and every solution if your teacher gives you 20 word problems and trying to solve it in 10 to 30 minutes. Okay, so you don't have that much time to spend on one simple question. So this is just a one handy method to find out your critical terms and plot them on number line. Okay, now what we need to do is basically go ahead and solve for another example. Another example basically means another new set of critical terms and new number line. Now the only focus I would tell you to pay attention on is the factorizing skills. Is that if you are poor at factorizing skills, you need to start practicing on factorizing things. Okay, you can practice with me. When I do factorizing, you can pause the video and factorize it and check with my solution. Okay, if you have a polynomial equation like this, now notice I have involved leading coefficient. In previous examples, I used to involve 1 as the leading coefficient. Now I've involved 4 as leading coefficient. So let's see what difference it makes in our critical solutions. Okay, so the factorizing is only the difference it makes is that this would happen and it would be greater than 0. Okay, now since we find out, if we find out the critical terms, we find out that if you plug in 0 over here, you would get a critical term like this when x is equal to positive 3. Now it turns out that one peculiar thing happens, that 3 over here we can all conclude that it's 3 and positive, but 0, negative infinity to 0 is what we would write, right? But it turns out that when you have 0, you can't write this like that. It's not including 0. Okay, so that's what happens when you're involving a leading coefficient. So this is the only thing you can possibly do to your question, or the question that will come up on the test. So how do you actually accomplish? By drawing the number line. Okay, so you have 0 and 3. But the only thing that would graph is this part, positive infinity. Now we can't say it also includes 3 because the quotient doesn't say or equals to 3. Okay, you know what I'm going through. So this would be positive infinity. Clear as that. Okay, now let's go ahead and solve another example. Now this example will include fractions, polynomial fraction, rational, what we talked about, rational numbers. That x plus 5 over x minus 3 is less than 0. Now the critical, you basically would find out is that x could be, to make it equal to 0, on the numerator it should be negative 5, on the denominator it should be 3. Okay, easy as that. Now turns out that you need to, the thing I told you, that it would be negative infinity to negative 5 and then 3 to positive infinity. You should recheck on this, because it does not work on every single cases. Because you're solving an polynomial fraction, it doesn't work in fraction, though it does sometimes. So what we need to do is basically do this. There's an easier method, negative 5 and 3 for polynomial fractions. So when you graph this on number line, it would be negative 5 over here and 3 over here. So it's involving the digits along this line. Easy at that. It's not involving digits over here, nor over here, not including 5, negative 5, oops, not including 3, including the numbers between them. And just to clarify this, I'll make a check over here so you know what's going on. Okay? Now this is easy one over here, what we talked about. As it gets harder, we want to be identified, thus we need to factorize the numerator and the denominator to find the critical terms. Okay? What I mean by this is that this over here was already factorized, already was easy, it's given to us as, is thrown to us as an easiest example it could. So what about if we have 2x squared plus 3x squared divided by x squared minus 3? Well, for that you need to factorize the things like I told you from previous sections and find out your critical terms. Check on this. If it's fraction, polynomial fraction, you use this, but make sure you check on it because sometimes it does work and sometimes it doesn't. One problem that I solved, it didn't work, and other problem it worked fine. Then you need to create a number line using this. Using this, you can basically plot it without even checking, because once you check this, it's more likely to be correct. Okay, so doing this, you find out the inequalities of what x can take on, of what the values of x can take on. So I hope you guys enjoyed this video. There's a Facebook page down in the description. Click on that, click the like button, it really helps me a lot. If you learn from this video, take a time to click likes, comment and subscribe because it really helps me out a lot. Thank you for watching.